All right, so 10.6 is called the change of base formula. And here is the formula. I want it in two places. I want it in your notes, and I would like it on your note card. So when you have something that is log base a of x, you're going to change it to log base 10 of x over the log base 10 of a. Why? Because your calculator only likes base 10. We count in base 10. We function in a society that uses base 10, and the calculator only likes base 10. Okay, so if you are given a log that is not in base 10, you're going to use this change of base formula that puts it in base 10, and then you can put it in your calculator. And it will calculate an answer for you. So we're going to learn how to do that today. So the first example number 1, we're going to take log base 4 of 7. We're going to use the change of base formula, which says that we're going to rewrite it as log base 10 of 7 over log base 10 of 4. And then we're going to do what's called finding the decimal value. Oops, sorry. Okay. So you're going to take your calculator and you're going to type, you're going to use the log button. Notice above the log button in light blue it has 10 to the power of x. That means it's already in base 10. So you're going to type the log button. It's going to give you the first parenthesis, and then you're going to type 7. So we're going to do log base 10. And so it doesn't show you the 10, but the calculator only does base 10. So it's in there. Okay, so we're going to do log base 10 of 7 divided by log base 10 of 4. Then you're going to hit the equal sign. Sorry. Log base 10 of 7. Close your parentheses. Divide it by log base 10 of 4. Then hit the equal sign. There we go. And we're going to use a wavy equal sign. So who knows why we use a wavy equal sign?
Because it's approximate.
Because we're rounding. Let's round to 3 decimal places. So the 1 in front of the decimal we keep, and then after the decimal we have 403. That's either going to stay a 3 or round up to a 4. And next to it is a 6, so it rounds up. So this should be approximately 1.404. All right? And it's that easy. All right? Example number 2. We're going to take log base 9 of 5. We're going to change it using the change of base formula. So we're going to have log base 10 of 5 over log base 10 of 9. You can even just write log of 5 over log of 9. When you don't have a base written, when there's nothing here, it's log base 10. And then you're just going to type it into the calculator and do your wavy equal sign. So you're going to do log base 5 divided by log base 9. Hit the equal sign, and we're going to round it. After the decimal here, we've got 732. It's either going to stay or 2 round up. In this case, there's a 4 next to it, so it stays. So 0.732. any questions on example number 1 or number 2? They're pretty much the same. Javen.
This section does it incorporate like some algebra in it as well?
We are, yes.
Okay.
Okay. So example number 3, we're going to just practice typing in a calculator an exponential 1.17 to the 9th power. We're going to do this on the calculator. Shrink it just a tad there. Just a reminder how to do this. I think we've done this once. So you just type 1.17 and then you're going to use the little arrow pointing up. It's called a caret. And then you're going to type to the 9th power, hit the equal sign. I got approximately, so wavy equal sign, 4 point, and then it's 108, and it's going to stay in 8 because there's a 4 next to it. And sometimes the directions might say something like express to 3 significant digits or figures. It'll either use the word digits or figures. How many of you have heard this in science? Bless you.
Chemistry.
Yeah, probably. So it's just going to mean any numbers that aren't what?
Oh, that's like a on the lights because it looks like a glare.
Yes, the middle switch. Leave the other 2 up, and if you want to close the door, you can too, because I can feel the heater going. Thank you. All right. One more example, example number 4. We're going to do the 5th root of 493. So if you take your calculator and you type in the 5th root of 493. So you type the 5 first, you're going to do the 2nd button and the xth root. Make sure it says the xth root, otherwise you're just taking the square root and multiplying it by 5 of 493. Oh, don't need that parenthesis. You're going to get something like 3.45. That 5 is going to change to a 6 because there's a 9 next to it. So we've got approximately 3.456. Everybody get the same thing as me? All right. So we're going to let x be equal to the 5th root of 493. And if we take the log of x of log of 493 to the 1/5 power, because the 5th root is the same as 1/5 power. And then we use, well, first we can take that exponent and move it back here, right? So we'll have log of x equal to 1/5 times the log of 493. We can take this log of 493, what we just did on the calculator up here, and substitute in that value, right? Which we got 3.456. And when we type it in, what do we, we're going to have to do log of base 10 of x hold on, let me, is 1/5, and we can type the log of 493. So you just go log of 493, hit the equals, and you're going to get 1/5 times 2.692, but there's an 8 next to it. So we're going to do 2.693. And then if we divide that number by 5, we're going to have 1/5 of 2.693. So divide it by 5. Oops, can't see the calculator. Hit the equal sign, and we get 0.5386. We'll go with that. All that's equal to the log base 10 of x. So if we rewrite that in exponential form, we're going to have 10 to the power of this, the 0.5386, equal to our x. And watch what happens. If we take 10, can you see that? Yes. To the power of 0.5386, hit the equal sign, we get the same answer that we started with up here, the 3.456.
3, 4, 5, 6. That's kind of cool.
Yes.